So sorry, my voice is kind of gone, but that's cool because I have a microphone. I did this 8 hours yesterday, and at the end of it, I was going through my tweets. You know, it's pretty bad when people are like, gee, I hope he makes it, and dude, what the hell is going on with your voice? I mean, people tweeting about your health is not okay. And so rest assured I'm not dead yet, and if I do die, I have instructions on how to send my body back home. Cool summit, huh? Last year, how many of you were here last year? It was actually just us. No, last year we were at the Barbican, which is a cool venue, but it was a little smaller, and it was a nice, intimate feel, but man, this is really cool because I think there's a lot of good energy here, a lot of cool talks. One of the things I hate about doing these type of events is that I don't get to go see all the talks because I'm usually busy doing other stuff. But the good thing is we record them. There's dude back there recording them, so I get to watch them later. Pro tip, download the video and run it at 2x. You can get through your whole summit, a whole summit in like a day. And I'll try to speak slower so when you do 2x, it actually sounds good. So, applications. That'll look funny on 2x. So, I'm going to do a little different talk. Yesterday, I did 8 hours of data modeling. This is not a data modeling talk. This is a different type of talk. And when I say hit the turbo button, it's kind of I'm being cute, but what I'm trying to hopefully relay to you is some of my experience as being a consultant in Cassandra, with Cassandra, and working with teams on making their life a little better. So I don't know if my name is Patrick McFadin, if you didn't know that, and I'm the chief evangelist for Apache Cassandra, which is a really killer job because I get to go around, talk to people like yourself, find out what you're doing, and it's really, I mean, it's like my dream job because I get to talk about Cassandra all the time. I get to do applications. I get to talk to teams and just be a nerdy engineer all the time. And I still cannot explain to my mom what I do for a living. So let's start out with here. 2014 was an awesome year for drivers. You know, when we started out this year, the DataStax had 3 formalized drivers for CQL. There was Java, C#, and Python. And those are great drivers. And, well, C# had a lot of trouble, but we'll fix that. And those are good core drivers. But since then, we've added Node.js, and we've added a Ruby driver. This is from DataStax. And now we have C++, which is currently in beta. And from what I understand, it's coming around pretty quickly. It is a really fast driver. And it's good, because with a C++ driver, it's going to open up a lot of things like PHP, an accelerated Python driver experience. Other, smaller like Go could use a C++, Rust. Yeah, how many people use Rust? That's going to change next year. So, and C# driver got completely refactored, and that was really cool because it needed to. It has been rebuilt and much better off. I work with our driver team at DataStax quite often, and it's just a really good team of people, and they're all application engineers. They get it, they're passionate, and they're moving fast with these things. And this isn't just a DataStax effort. This is one of the things at DataStax as a company we decided that we wanted to really help. It's hard to get drivers in community, right? Because it's a full-time job, and it's not just submitting a patch here and there. It's a lot of work because you have to test it and everything. But we work with a lot of people in community. So, for instance, the Ruby driver came from CQLRB, which was in community, and we worked with Theo on that. And there was a lot of collaboration in community. And all of these drivers are open source, right? So you can go out and download them and use them and contribute to them and do pull requests, and I see that all the time. There's also some great community drivers out there. Clojure, there's actually 2 really good ones. It's kind of hard because when you have 2 drivers that are really good, which one are you going to use? And there's a Go driver, Erlang driver. There's Rust. I've seen some Rust drivers, some Scala stuff going on. So those are the ones that are more formalized to Clojure, Go, and Erlang. Using Erlang with Cassandra is kind of a funny thing, but anyway. So why drivers? Because the driver support for CQL opens up a lot of possibilities, right? And when you're using Cassandra, it's an application database, right? You're supposed to write, your application is an endpoint to store data. So most times developers are using Cassandra. It's not just a DBAs type database. And it's not BI people, people who work in business intelligence. It's application database. So these APIs and these drivers are really important. They have to be rock solid, and they have to be fast, and they have to be feature rich. And they have to express what is in Cassandra really well. So I'm just going to say this. You probably saw this slide this morning, but Cassandra performance, that's not a big problem right now. It's awesome that we're getting faster, but Cassandra performance it's fast. It's a fast database. It's meant to be a really fast database. The performance we saw this morning, with the new 2.1 Cassandra, it's pretty fast. You should not have a lot of performance issues. If you do, you probably created them yourself. So why do I say that? Because I do a lot of consulting. So if Cassandra is fast enough, if we can get the job done, just as a database, it has all the right things, then here's the problem I see all the time, right? Is you have the ability as a developer to do the wrong thing or the right thing, and it's not like you're a bad programmer. Sometimes I'll talk to teams, I'll be like, hey, why don't you do this? And they're like, I've never heard of that. Oh, I should do a talk on that. So I'm doing a talk on that. But you don't want to be in this situation where you got this killer database that's going to kick ass, and then you spoon feed it, or you do something that's not going to make it as performant as possible. You want to just do this, so you can do some simple stuff. Use the APIs correctly, and those APIs are built around what Cassandra can do, and actually help exercise some of the better features of Cassandra. So it's really a complete system. If you're looking at a system, Cassandra is not only just a server, but it's also the clients. The clients participate pretty heavily in what the cluster is doing. So it's how you use it. So let's start out with a couple of really easy ones. And I'm going to start with this. Prepared statements. Simple beauty, right? And I have always amazed how many people never use prepared statements. And the question I always get is, well, what's the difference? There's a huge difference. So what are they? Let me explain how a prepared statement works. So a prepared statement is all about this progression in your code. And now I'm going to use some generalizations. CQL drivers should all have a prepare, some sort of a prepare. But how does this work? So when a client says, hey, prepare this statement, and does a session.prepare, that statement will have, here's a select statement, and it has a question mark for the variables that you're going to bind later. So the prepare is all about, here's a statement, and I'm going to use this statement over and over again and bind the variables at runtime when I need to. This is exactly like what relational databases have done for a long time with JDBC and those type of drivers. So we have a prepare statement. So when it does a prepare, it actually goes out to it goes and takes to the cluster, and it says, okay, entire cluster, we're now doing this preparation. So what does that mean? So it parses and hashes that statement. So it's pre-parsing. The parsing action is a string manipulation. And as we know, string manipulation is the fastest thing you can do in Java. Not. So when we pre-parse that, we parse that statement, and then it's hashed. It's just an MD5 hash and stored. So that pre-parse statement is hashed through an MD5. And then once it's hashed, it says, OK, now we have a prepared statement. And the hash goes into back to the client. It says, here's the hash. And then it's cached as well on every one of the servers. So now you have this nice little setup where when I want to go use it, now I have, whenever I go to bind and execute that, that particular prepared statement, I can use, I'd say, well, ID is going to equal 1, and plus I'm going to send over the prepared, the prepared statement hash to the cluster. And when I go ask a server for that, and when I execute that query on the server, then instead of parsing that statement again, it'll just, you look up the MD5 and it'll say, OK, I already have that parsed. I'm going to bind the variable and run that query. It seems like a pretty simple thing that is it too much optimization? But there's a lot you're missing there. So that you're skipping a whole bunch of code when you do this. It's a shortcut. And especially on something most likely you're going to run over and over. So they combine to the pre-parse query, does the bind, executes, and sends the variable, sends that data back. That simple action right there really makes a difference. And how much of a difference? My buddies over at Netflix tried this out in production, and they ran a bunch of tests. So the non-prepared statement's down here at 5,000 or at 500 inserts per second. And then up here, the throughput went to 2,500-ish or more. So that's a 5x improvement on throughput, just using a prepared statement. And this is the type of thing that you would prepare you do a prepared statement early on. So I'll show you some code. You do a prepared statement early on like this, and you say, here's my Java code, for instance, or Python. If you notice, they're pretty similar, where you create a prepared statement, a bound statement takes that, and then when you execute it, you bind the variable to it. And it's both Python and Java and Node.js and C#. I mean, all the language drivers do this. Closure. And when you do this, this is free speed. This is not that hard. So you could see, like early in your code, you would prepare that statement. And once you do that session prepare, it's now cached on every server. So knowing how this works, here's the other side of the coin. Don't do this. Because, and I've seen this done, and it's like, OK, great feature use, bad placement. You know, can we just copy that or cut that one piece and move it up a bit? Because what happens here is when you're just going to say prepare, 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 prepare over and over again. And what a prepare does is it spreads out that all of that to the cluster. Now, that's just going to hammer the hell out of your servers, and you get zero benefit from it. It's just going to be like, you might as well just use session execute and leave it at that. So it's an anti-pattern for sure. And this is like one of those, you know, when you're trying to solve a performance problem and you see this, you get real excited because it's going to be a short day. Like, oh, move that, recompile, I'll leave now. But this is a typical pattern. I see this, it happens, but it's one of those things that you get in your own way, right? You're using the right feature, you're using it the wrong way. So execute versus execute async. Now, why would I do that? Well, here's execute. OK, boom, cannon, right on. Well, here's execute async. Now, if we're in the middle of a skirmish, I want that one. And this is my cute analogy that shows the difference. When you do an execute, it's a single. It's just boom, I'm going to send one thing out. When I use execute async, I get the advantage of being able to do things in parallel and take advantage of some things that Cassandra already gives me, like my data is distributed across multiple servers. That's cool. If I have a 500 node cluster, I would love to spread out the load. I want to run things in massive parallel. And this is all brought to us by the magic of Netty. And this is what I'm a good representation of what's going on. So when you do request pipelining, you have this one connection from the client to the server, and each one of the servers, the client connects to each one of the servers in the cluster. So whenever I send requests over, when I use async, it will send the request over, and then the responses get received asynchronously. I'm no longer doing a blocking call. So in a blocking, just an execute instead of an execute async. If I just run execute, it sends the request and waits for the response. Now, that sounds legit, but in a case where I'm going to be doing a lot of inserts, for instance, or something like that, then I want to do something where I'm going to run a lot of statements, hopefully at the same time, and let them run on each individual node that's going to be collecting that. And one of the important things about this is that you're collecting a future. So here's some sample-ish code. I try not to get too language specific because this is a feature that's on every single driver. And actually, if you use Node.js, you're already pretty smug because there's no such thing as a non-asynchronous call, right? Because that's the way Node people work. Everything's asynchronous. So if you're using Node, forget what I'm telling you because everything you do is asynchronous. So how does this work, or why does it work? So when the client says, in a for loop, for instance, if you're doing an insert, instead of doing an execute, you do an execute async. When you do that, you collect a future. So now that is a non-blocking operation. The future is just a placeholder for that request. And it'll hold the response, but it's non-blocking. If I just did an execute, it would just sit there waiting for the response. And so the futures are really great. And so whenever let's say I was going to insert a lot of records, those fan out in parallel. And I got to reuse that cool graphic. Isn't that cool? So those fan out in parallel. So as I'm inserting things, they're going off in a parallel manner. And that's awesome because my code is not blocking. So I'm in the middle of doing something here. So I send those out. Whenever I run the future.get, that's when it blocks, and not until then. And if you're really good at concurrent code, which I'm sure everybody here is, then you can figure out some ways to use like mutexes and things like that to gather those almost in a parallel fashion. I have some code that I wrote that I got a lot of help with because I suck at concurrent. And when it sends out those asynchronous requests, basically the slowest all of it will be the one slowest response. So everything comes back pretty much at the same time, and I collect them all. And using a mutex, you can wait for all of them to be returned. So you're taking advantage of the fact that you're using a massively distributed system instead of treating it like a single point of failure. And that can be really fast. I'm always amazed when I see people just using an execute, not an execute async. I'm like, you're missing all the free speed. Again, another short day of consulting. So how about batches? Now, this is kind of my current rant. Batches are my current rant. I'm not a big fan of what batches do because they turn into a problem. So here is a batch. Going back to my analogies, batch is like a battering ram, right? And versus you're gunning it. Now, a battering ram sounds awesome if you're taking down a castle. It's horrible whenever you're writing database code because why am I calling it a battering ram? Let's get into that. Well, it's potentially a battering ram. So what does a logged batch do? So when you create a batch, you're collecting all of the statements on the client. You send all of it over. So whenever the batch is accepted, it's all done on one node. All the actions are logged on two replicas. So if you put a bunch of statements in there, it now has to log them all. So it's okay, it creates a commit log of all of those. And then it puts it on two replicas. So that's a lot of work that's getting done right there. Then the statements are executed in sequence. The results are then collected by the one server in your whole cluster. You got a huge cluster. One server is now collecting all those responses and then it has to go back to the client. Now, why, that's how it works. So the good news is that batches have a good point. I mean, I'm not going to just say and tell you batches are bad. The reason batches are good are for what they're used for that reason I just told you. So here's a use case. So I have 2 lookup tables that basically store the same information but in a different way. So those are 2 things that will have to be updated at the same time. If these become out of sync, my application code is going to suck because I'm going to have to figure out how to make these work, right? So I have a comments by video and a comments by user. So if I ever add a comment to this table, to my comments table, I would have to update both of these at the same time. Now, what's my option? Going into application code and managing that situation in application code. So that kind of sucks. So I would rather use a batch to do this. So both inserts are run. They are logged. So if there's a failure somewhere along the line, it will finish that batch. So both of those insert statements are run. That's the awesome part of log batches. That's what they're there for, and that's why they're there. So I'm not going to tell you not to do that. That's the way to do it. Now, here's a very typical conversation I have with someone. And I have this about once a week. So, hey, I was doing a load test and my node blinked out. And I say, well, we're using a batch by any chance? Because I hear this all the time. And by that, they're like, one node just dropped out and then it picked up, and then another node dropped out and it picked up. And I'm like, oh, Cassandra sucks. And then, so if I use my magic ball and I say, are you using a batch? And they're like, whoa, how did you know? I'm like, and how big was that batch? Oh, 1,000 inserts, and then I give them the fry. No, really. So that situation, what is that doing? And it's typical where you have these massive batches and you fire up your load test and you just start pounding the hell out of your poor cluster with the wrong tool, a battering ram. So how does it work? Well, so if the client decides to, and I've seen this, people use this as a potential optimization, where it's like, hey, I'm getting a bunch of sensor input, and I'm gonna put them all into a single batch and just send them down. That's more efficient, right? Yes, it's absolutely more efficient if you're using Oracle, not Cassandra. I use batches all the time when I was in Oracle DBA because it was on a single server and it actually pipelined a lot of the requests. It was a very efficient way of sending a lot of information down. It did use one connection, right? Well, because let's go back to we're using Netty. That means there's only one connection. We're not creating a whole bunch of connections for this. But people will developers will put a bunch of mutations, a bunch of inserts into one batch. They're like, hey, one server, here's 1,000 things to do. That 1,000 things to do have to get done. Here, I'm just going to throw more at you. Good luck. Good luck. Oh, yeah. Oh, yeah. Then I get that message. Dude, my cluster sucks. Cassandra sucks. That's the problem. And if you look at what the problem is, usually like at GC, it just starts garbage collecting like crazy because all of that stuff is sitting in new gen and it gets promoted into old gen and the CMS starts firing up and CPU gets eaten up and then disks and then dogs and cats are living together and it's just really ugly and there's a mess and you get this. So what do? So follow the rules. The rules are here, right? So keep the batches small and for atomicity if you can. And keep in mind that, so I had heard this so much, and this is a good lesson for community people, is if there's something that's bugging you, create a JIRA. So this is actually a JIRA that is now in production, or in Cassandra, mainline. I created this, so now there's a warning on large batches of 5 kilobytes in size. Not how many statements, but how big it is, because that's usually the problem. So there's a warning. You look in the log, it says, hey, dude, that batch is pretty big. What are you doing? So that was in there for a while, and I kept having the same conversations, and I'm like, didn't you see that log entry? Oh, there's a log entry. Okay, fine. New Jira. So that's a new Jira, and that's in 3.0. We will now fail on a large batch. And if it goes over 50K in size, I just put 10x on it, it will fail. And why? Because I love you, man. I don't want you to ruin your cluster. So this is going to prevent, this is like the safety interlock. And so this should be a guide. If this is good enough to be put into code, it probably needs to be thought of well before it gets to the point where it fails a batch. It'll just throw an exception and say, too large of a batch, dude. That's what you get to do when you write your own code. So what's the alternative to this? Simple. Instead of that, hey, you already know the answer because you guys listened to me. Do this. Use execute async and just send those out in parallel. And what you're doing now is those requests will then go to each one of those servers individually instead of going to the one server and nuking it, all right? And it's more distributed. Actually, it is distributed, where the other one is not. So this kind of thing is what you want to do. There's actually a nice blog post one of our solution architects at DataStax wrote. It's really funny. He's a consultant. He sees it all the time too. And I've seen people actually think that Cassandra really sucked because it can't take a load. Like, whoa, what? That's like, I hate Oracle because it's not relational. What? Of course it is. So the last thing I'm going to talk about is this caching mechanism that is now a part of Cassandra 2.1. And so this is a future tense thing. So old cache. If you had been looked at row cache at any point before 2.1, which is probably everybody that had used it, you kind of got that warning like row cache isn't quite what you want it to be. It's not. It doesn't work as well in a high volume load. And why is that? Because when you need this little part of your CQL rows, what happens is that the row cache actually caches the entire storage row. So if you have a 400 megabyte storage row and you need one little 5 byte value out of it, well, you just cached up megabytes of data. And that is not very efficient. So the new row cache is much different, and it's more thought out in the way that you and I will probably want to do it. So I need this, so how about just caching this? And that's what it does. It caches the CQL rows. So when you use it like this, so I have a table here, I could say, and caching rows per partition, 20. So it's only going to cache 20 rows per partition. What does that do for you in the long run? Is that it probably, like if you have hot rows in your like hot rows in a partition in a particular table, it's just going to cache those. And that's good. You can tune this. You can say 5 rows per partition, 100 rows per partition. It's much more efficient. Now keep in mind it's a write-through cache. So if you change something in that first 20 rows of partition, it will just invalidate it and reread it on, later on. But what do you get out of this? I did a little load test, and I had 1 million records, and I was reading random records inside of it. And after a while, after about a minute, it just dropped down. I went over that magic 80% hit rate on cache, and it just stabilized. And this is in milliseconds, how many milliseconds per read. And if you look at the milliseconds per read, it started up to like 1.1, and it just dropped down to 0.29 or 3 or whatever that is, and just leveled out. And that's what the cache is supposed to do, is give you a much more consistent low latency response. And so if you think about those things that are always getting hit, it's what you probably want to cache, consider this before you do something like stick memcache in front of it. Because memcache in front of it is just more complexity, and complex things fail in complex ways. Final topic, my annual rant of storage. Whoops, I got a little fast, I got a little ranty and got crazy. If you are using a system that is giving you 18 millisecond seek times on reads. And again, I just keep seeing this, so I have to reiterate it again until everybody gets it. Cassandra has to read from a disk. And if you're looking for low latency reads and you put a 7,200 RPM disk underneath it, don't come after me, please. Dude, it must be JVM tuning. No, it's rotational physics. 18 milliseconds, 12 milliseconds, that's the kind of seeks you're gonna get. We did a bunch of load tests on hard drives. This is the kind of stuff we got. We know that. So what do you use to fix that? You use low latency drives. Like this top one is a Samsung 840, and the bottom one here, that's flash PCI, that's a Fusion IO drive. That's 70 microseconds. Now, what do you think that does for your latency on your reads? Oh, it's great. And your P99s and P95s are going to be pretty good. So this is my annual rant. I do this once a year, right? No, I do it every time. But just think about this. I've given you a bunch of stuff here to look at. Cheap, easy. These are things you could probably flip open your laptop right now, go look at the code you wrote for Cassandra, and find some stuff. You could do these little things and get a lot more performance out of this. So that's it. That was quick, a quick talk. I think I have time for some questions. Where's my moderator in the back? Do I have any time for questions? One or two? I got 10 minutes for questions, right? Okay, good. Yes?
For the prepared statements, what if you have more instances of the driver? So you have multiple drivers talking to multiple nodes in the cluster.
Right.
You have to prepare a driver.
The session object stores the hash for the prepared. So yes, you would have to do inside, if you had separate drivers going, every session object you create, you have to do a prepare. All right, that could seem a little inefficient, but if you only had 4 drivers, say, you did it 4 times, then you're done. The rest of your code running will be fine. But it is tied to that session object. So if you close the session object, then you have to re-prepare your statement. Yeah. Yeah.
Is there a performance difference between index-bound statements or just binding by name in the driver? I'm talking about the C++ driver.
Ah, the C++ driver. I'm not really sure, actually. So you're saying that in binding, like how?
Values by index or by name?
I don't know if there's much of a hit on performance there because if you look at the long, like the total budget of time that it takes for request to response, I mean, how long does it take in the difference, finding something in an array? Microseconds? So yeah, it may be a few microseconds different, but in the big scheme, it probably isn't a big difference at all. Yeah. Yes? Right. So the first question was why the size and not the number of statements? Because what it comes down to is the size is what's going to cause an impact on the server. That's going to drive the resource contentions and that issues. It was the easiest thing to look at. So you could have 1,000 mutations of very small amounts or 5 of huge amounts of data, right? It's too arbitrary to know exactly what it is, but what I looked at for the root cause of the problem is that you're putting a lot of bytes through the JVM, and 5K, after I did the math, 5K was where I started seeing some problems if you're hitting it really hard. It doesn't seem like a lot, but it adds up when you're doing thousands of those a second. And so it was strictly based on how it manages the resources. It's just not a good idea. The second question, I think you were asking about like doing a batch on a single partition. Okay, that's not so bad. A single partition means that you're only going to one server. The times that I've seen people do that on a single partition is pretty small. Now, why would that be a difference? Well, a batch on a single partition, a partition key gives you locality, right? So that's going to be run on one server. You're no longer fanning that out to the rest of the cluster to collect responses. So a batch on a single partition isn't so bad. And so in this case, now if you're doing that and you run into this problem like, oh great, now you put this wall up so I can't go past 50K, it's a tunable. It's in the YAML file. So you can turn that up as much as you want. If you're doing batches on a single partition consistently, then you can tune that any way you want. Every single time I see a problem, though, it's not on a single partition. So a single partition shouldn't be a problem, though. Yeah?
Couldn't you change the batch state to do automatic asynchronous stuff?
Yeah.
Because that would be quite neat because it's so easy to
Yeah,
do.
I've discussed this with drivers, and they're hesitant to try to guess user intent in API. And I've been argued out of that before, because even in statement is another one, right? In statement should be run in parallel, but it isn't. And again, the API is very clear. So I'm out of time, huh? All right. So that was the last question. So both of those are just really, you don't want to assume user intent, right? And I guess from the purity of it, I understand. That's why I'm up here. Education, right? You just say, hey, okay, this is the way it works. Don't do that. Okay, let's not do that. All right, well, thank you very much. You can follow me on Twitter for more.